on some combinations and permutations. So one of the things, I've probably noticed, I think combinations are more prevalent than, say, combinations when it comes to, what I've seen on, GMAT practice exam and things like that. But we tend to do a lot of combinations in the webinar. So maybe what we can do is start with permutations today. One thing I want to note that I always like to talk about is the fact that combinations especially relate in a big way to probability. So once you have a good way of dealing with combination problems in general, a lot of times you should be able to quickly handle those in a probability perspective. When you're talking about favorable over total outcomes. For me, once I kind of figured that out, it was kind of a game changer. So, just something to think about and, make sure you're in a position where you can utilize that to your advantage. Now, permutations, combinations, as I said, we usually do combinations. Remember, in brief, I'm sure a lot of you guys know this because you've studied this topic. Permutations order does not matter. Combinations order does not matter. Permutations, it does. So when we talk about selecting a team of people, that's a combination. Order doesn't matter. But when we talk about selecting a team where you're placing a first baseman, second baseman, and third baseman, order does matter. That's a permutation, okay? I think sometimes people think that maybe it's hard to know when you're dealing with a combination and permutation. I find that to be something that kind of happens in our heads because we've heard people talk about it. It's really not that bad if you truly just think about it, think logically about what kind of arrangement you're doing, and you shouldn't have an issue there. So we're going to go right into permutations, and we're going to do permutations with indistinguishable items. So here's the first question. Give you guys a minute or two, then we'll talk about it. All right, so this one hopefully wasn't too bad for you guys. So this is the type of question, yeah, exactly. So when you have a question like this, there's a process. Now what's interesting is we kind of use this process in probability when we're dealing with multiple outcomes and we're figuring out how many, outcome arrangements we need. So for me, the easiest way to do it is just to write out what we're dealing with. So 1 gold, 1 silver, 2 platinum. Notice I did P and P and then a titanium. So there's 1, 2, 3, 4, 5 total items in the top, but because the 2 P's repeat, you have to divide those out. So that's where the 2 factorial comes in. So it becomes 5 factorial over 2 factorial, which is 120 over 2, which is 60. So had it said contains 1 gold bar, 1 silver, and 2 different platinum bars, then you wouldn't have divided out by 2 factorial. So just keep that in mind, and obviously you do it for every amount of repeats. So if there was also, 4 bronze bars that were identical, you would have divided by 4 factorial as well, but then you would have had 9 factorial in the numerator because you would have 4 more items. So just keep that in mind. Now, the next thing that they like to test on as it relates to permutations is when people or things have to be grouped together. Now, there's different ways in which that can happen, meaning how they can ask those questions. Sometimes it can be they want them together, and then sometimes it can be that they're not together. Now, the not together is going to seem harder than the together, but you're going to see it all boils down to events that are mutually exclusive. So that way you can use a really great formula to deal with it. And we can circle back if we have time and deal with mutually exclusive events with combinations too. All right, so this is an example of people having to stand next to each other. Do this out, and then we'll talk. All right, so let's go through this one here. So we've got these people all lined up, right? Now, Rue and Vic are going to stand next to each other. Rue and Vic is 1. Then you've got Sol, Tak, and then Woo. Okay, so we have 1 to start. Let's just count 1, 2, 3, 4, 5, 6. And then we've got our 6 people here, right? So what you do is you take how many slots you have. We have 1, 2, 3, 4, 5 slots. You make that a 5 factorial. So there's 5 factorial ways to arrange those slots, but you can't forget about this slot here. That's RV. So that's times 2 factorial. So we have 5 times 4 times 3 times 2 times 2 again, because that's the 2 factorial, so that ends up being 240 total. So now what I want to do next is I want to do something similar, but I want to do it with items that can't be next to each other. So let's take a look at this here. So I'll give you guys a few minutes and then we'll talk about it. All right, so work through this one here. All right, I see some answers coming in here. All right, cool. So a lot of good answers. So these, I'm sure you guys who got this right, I imagine you guys understand this concept of mutually exclusive events, right? Like total is equal to basically the songs being together plus the number of ways of them being not together, right? Now, because they're either going to be together or they're not. But the thing is that the total isn't bad to solve for, and together isn't bad to solve for. Not together, that's a little bit harder. So instead of actually trying to figure that out and doing all the scenarios that exist there, we're just going to do the total and the together scenario. So same deal, almost the same deal as the last question. Now that we know that, total is 6 factorial, that's 720. Together, we just do our slots, right? Now we know that which songs can't be together. 2 of those songs are heavy metal, and they can't play them together. So we're basically saying heavy metal 1, heavy metal 2, and then we don't even care what the other songs are. We'll just call them A, B, C, D, and it's the same deal. How many slots do we have here? We have 1, 2, 3, 4, 5 slots, so that's 5 factorial, times the extra 2 factorial from these here, right? So that's 120 times 2, that's 240. Subtract, sorry, this pen tool. Subtract the 240 from the 720, and that's where we're going to get the 480. So looks like you guys are pretty good with that. I just want to do one more, and then we can even look at how this can play a role in certain combination questions. Because yeah, this idea of mutually exclusive events is really helpful. And remember, we do it in probability. When you see the words like, how many ways can at least, 5 heads be flipped or something, you just do 1 minus no heads being flipped. That's also mutually exclusive events, so keep that in mind. All right, try this. I'll give you guys a couple minutes. see a lot of good answers here. Did you guys find this any more difficult than the previous one just because the numbers were different, or did you feel like your process was pretty rock solid? You can type that if you have any thoughts. I'm assuming you guys thought it was the same. Yeah, and it is similar. I mean, they can adjust it any way they want. If you know what you're dealing with, then you're going to continue to follow the same process, which is great for questions like this, because seemingly they are difficult. So the process here, and again, we don't have to write out the equation because you know what it is. It's the total, which is going to be 5 factorial, which is 120. But we will write out the rest of the part. I'd say this is this is like an 80th percentile type of question, because the thing is, if you don't know how to do it, you're kind of dead in the water. So these planes can never be together. A1, C3, E5. Okay, that's one slot. Then you got to look at what we haven't touched or talked about, B2. So A1, C3, D4, that's it. So there's only 3 slots, which relates to 3 factorial. There's 3 of them in one slot. That's an extra 3 factorial. That's 36. So doing some simple math, 120 minus 36 gives us 84. So that's that. So nothing crazy here, right? Just following a process. Now, sticking to the same process, I want to do a couple more mutually exclusive problems, but now we're going to kind of shift gears into combinations. We'll probably do 2 more questions, and we can do some Q&A here. So why don't you start with this? And again, this is now in combination land, just keep that in mind. So again, based on dealing with mutually exclusive events, do you guys feel like this was pretty straightforward as well? And if so, I have an important question for you. Once you tell me if you thought it was simpler than or the same or harder than the other ones we did. And as you respond to me in the chat, I'm going to just write out my equation. Total is equal to at least 1 Iranian plus 0 Iranians. Okay, well, I'm going to assume that you guys thought it was just as easy. What I am wondering about, though, is had you saw this question first, and I didn't mention mutually exclusive events at all, okay, you found it harder. Good to know. Would you guys have used this formulaic approach to solve it, or would have you tried to do out every single scenario possible, including at least 1 Iranian? Because clearly I was leading you guys to do this. I'm just curious if that would have been the case. Question 1 in the webinar today. All right, well, I'll assume that it wasn't going to be the case and you've learned something here. But so when we're talking about, oh, wow, even if you didn't try it that way. Okay, well, it's good to know. So a rule of thumb for me is when you see the words at least 1, you do it this way. It's quicker because then you're not having to do all these different scenarios. And remember, the more scenarios, the more math, the more potential there is for a mistake, right? So we don't want that. We want to avoid as many mistakes as humanly possible. So with that in mind, total is just 9 factorial, okay? So because we have, oh no, excuse me, not 9 factorial, we have 11 factorial because there are 5 players from Turkey and 6 from Iran. Now that's a pretty big number, but you can kind of do it out, you know, incrementally to come up with the answer of whatever it is. But it's not, you know, it's not anything crazy. Now, the other thing too is, again, the whole idea, or excuse me, not 11 factorial, 11 choose 4. The whole idea behind this is that you're having to do less steps. So remember that. There's a reason why we do it this way. So there's 11 total people. We're choosing 4. So actually, yeah, 11 factorial would have been huge. We have this, and then we have 4 times 3 times 2. So yeah, this number isn't that big. You see the 8 cancels. That goes into 3. So you have 110 times 3. So you have 330. So the reality is, at a bare minimum, you know the answer's not D. Now, how about how many ways can we get 0 Iranians? Well, we have 5 from Turkey. We need to choose 4 of them. That's the equivalent of 0 Iranians. 5 choose 4 is 5. 330 minus 5 is going to give us 325. Any questions about that? Does that make sense? All right, cool. So yeah, I mean, look, as I told you, this is the type of stuff that's happening in probability too. So like, you know, get used to seeing at least 1. Now, if you see the words at least 2, don't do it this way. Can you? Yes, but it's mathematics, you know, acrobats. You don't want to have to in your head be saying, well, what's the opposite of at least 2? Like that's not clear, and it's not clear on a test where you have to do things in 2 minutes or less. It's very clear when you see the word at least 1. What's the, you know, the event that doesn't include at least 1? Well, that's the event that has 0. So again, just put yourself in a position where you're not getting too cute with these questions. In my opinion, anything but at least 1, you do the scenarios. At least 1, you do the mutually exclusive events. So yeah, the answer here is D, 325. So, all right, well, we can actually pause there. I think this was good. We covered a pretty good topic today. We have a ton of this in our course. We have a ton of this in the combinations chapter. Really, really expansive lessons on this. If you're using TTP, read them, follow them. I think in general, combinations and permutations for most seems to be an intimidating topic from the outset, but if you really get into it, it's actually not that bad. So any questions in general that anyone has? Any questions about your studying, about target test prep, anything like that? You never know how many of these questions are going to be in the exam. That's the whole difficulty of the GMAT. If we knew, we'd probably all be crushing the test because we'd study accordingly. The difficulty of this, I'd say it was an 80th percentile type question for sure. I don't have a limit to the number of formulas you need to memorize. I think you just need to memorize the things that you know you need to readily use on the GMAT. So I wouldn't pick and choose. I would just memorize everything that seems relevant. Next session, yes. It won't be next week, though. I don't think. But yeah, whenever the next session is, it'll be probability. Well, I did do 11C4. I'm just using a method we call the box and fill. This is like an iteration of the combination formula that allows you to skip a step. So it's something that you can check out in our combination chapter. We show both. We show the combination formula. We show box and fill. It's not anything crazy, but it's just what we do. Again, how probable is it to get a P&C question in GMAT? I really couldn't tell you. And I don't, to be honest, I don't like to talk in those terms. I don't think it really does much for anyone. Can you see it? Yes. That's really all that matters. If you're taking your GMAT based on probabilities, like, it's probably not going to be a great time for you. I would just learn the stuff you got to learn. Yeah, we can probably in this month have a statistics section. If you need to extend your CTP course, we can help you with a discount. So just let us know. Okay. Let's see here. Can you show what method to use the question? No, we're not going to go through any more questions, but I will tell you that we have what you just asked in our combination chapter. So you should totally read it. It's fantastic. But I will tell you, yes, if it's at least 2, you would do the scenario out. It's not probabilities, but you would do the combination scenarios out, and then yes, you'd add them together. That is what you would do. But again, we literally have this question with the Iranians and the Turkish players with an at least 2 scenario in the course. Any other questions? All right, well, that's it. I think this was good. Again, as I said, I think we covered some nice stuff. We changed it up a little bit from some previous combination webinars. If anyone needs anything, reach out to us. Studying, target test prep, anything, we're here to help. Glad you guys were able to come today. So have a good rest of your week. Study hard. And as I said, reach out to us if you need us, okay? We're always here to help. Talk to everybody soon.